On this episode, we showcase the journey of Here Technologies, a world-leading location platform that's transforming how their customers interact with digital representations of the physical world. Hear about their collaboration with the AWS Prototyping team, where they've developed a next-generation search platform that seamlessly converts natural language query into advanced automotive driving simulations and scenes. Well, I'm excited to welcome Kristin Thompson, Senior Product Manager for Advanced Driving for Here Technologies. Kristin, thanks so much for joining us.
Thank you for having me.
And also joining us from Here Technologies, we have Julian Gonsior, Senior Product Manager for Automotive Solutions.
Thanks. Pleasure.
From AWS, we have Shane Madigan, our Senior Engagement Manager for Worldwide Prototyping. Shane, thank you for being here.
My pleasure. Great to be here.
And also we have Patrick O'Connor, our prototyping engineer from our worldwide team. Patrick, great to see you again.
Great to see you again. Thanks.
Well, Kristin, for our worldwide audience, can you tell us a little bit about Here Technologies and your mission?
Yeah, absolutely. So Here Technologies we're the world's leading location platform company. We have a strong global footprint and presence in the automotive space. We primarily do a lot of business-to-business work with in-car navigation systems, ADAS systems, and automotive driving.
So for listeners who might not be familiar with the automotive space, can you explain what ADAS means?
Yeah, so ADAS is Advanced Driver Assistance Systems. So they're the systems inside the vehicle that enable advanced driving technology with the car performing some of the driver functionality.
Wonderful. And I understand, Julian, you both work in this space. Can you tell us a little bit about what you were trying to achieve?
So one of our missions is that we are making the lives of our customers easier. So the main customers are the automotive OEMs, and we are helping them to develop the right products in the automated driving domain. So we are helping, for example, level 2+, level 3 systems, so level of autonomies to bring them and help them bringing their systems to the market. And we do that with highly automated and high definition products that we do have, like our Here's HD Live map, so our high definition map.
And those levels define the level of complexity and automation.
Exactly. There is it's SAE levels, the Society of Automotive Engineers, who define these levels. There is like a scale from 1 to 5. And where we come into the game is everywhere from 0 to 4 at the moment, I would say. There is not really 5 at the moment. But the levels really interesting are L2+. It's not a real official level, but L2+ is everything where you can basically take your hands off the steering wheel. You still have to watch the street, but you can take your hands off for a undefined time on the road, for example, in Germany, and you drive from Munich to Berlin and can take off your hands there. And level 3 is basically where the car really takes over the driver's task, and you can also read a book, for example, and have your eyes off the road.
Okay, exciting times, right? Tell us a little bit about what we were trying to achieve here.
So we do have, as I already touched a little bit, our high definition map. Here's HD Live map. And we are using that already together with our customers for in-car introduction use cases. And together with AWS, we wanted to find out, can we also help our automotive customers to use our product that we do have on shelf already for development use cases. So help them within their development task and help them within simulation activities. So use it to generate virtual environments, for example.
And that simulation helps reduce the cost, as I understand it, for all the testing that has to happen. Is that right?
Absolutely. So if we can help automotive customers to generate synthetic scenes out of our map, out of our HD Live map, we can drive costs down for them, and we can also help them being faster to market in their autonomy projects and programs.
Absolutely. And all different scenarios, right?
the complexity of the scenarios that you're able to simulate.
Absolutely. I mean, there is a difference between scene and scenario. So based on our map, we are creating the scene. So that is basically the part of the world that goes into the virtual environment. Scenario is then if you add like dynamic information as vulnerable road users, for example, traffic and so on.
Fascinating. So Kristin, can you tell us a little bit about how you came to work with AWS and the team?
Absolutely. So here in AWS have had a pretty long-standing relationship. We leverage AWS's products within our own ecosystem, and it is something that we've wanted to do is really expand our partnership with Amazon and AWS in general, because we see a lot of opportunities for us to work together. And this was something that we were interested in partnering with AWS on because we had the opportunity to really leverage our assets and also the assets that Amazon brings to the table and AWS with development. So we bring the data, the map data for this situation. And from that data, of course, all of these different scenes that Julian was mentioning can be created. It's real world data. So it's highly valuable from an automotive testing perspective. And AWS would bring to the equation, the scalability of the system, the ability to run the simulation in a cloud environment, and also their natural language processing and AI capabilities for enabling a good user experience for identifying scenarios and scenes and doing search of our data. So it seemed like a natural pairing for us to work with AWS on this opportunity.
Great. And Shane, can you talk us through a little bit about what the scope of the project was? What were we trying to achieve with this prototype?
So we were introduced to Here through the account team. And so we worked with Here to make sure we understood their business challenge first. We want to make sure as our first engagement with them, we really understood what they were trying to achieve in the environment that they work in. And so we quickly kind of worked down through what their needs were into a few key success criteria and a few key objectives. And so the focus of this prototype was really on a few things. First and foremost was to create a streamlined data extract process out of their tiling system. It's incredibly complex, as they mentioned. I think if I've read their website correctly, they've got 1,000 different parameters in that tiling system. So that was the first thing, is how do we get the data out of that and then merge it into a format that is readable? The second half of that project, the second major objective, was then to apply generative AI capabilities to create that natural language interface to allow the end user to quickly use natural language to find and identify those scenes that they're looking for their simulation testing.
Kristin, what are in these tiles, this complex data?
Yeah, so the tiling system is really a way of breaking down the world into small, loadable, and manageable chunks, right? So a tile is a 4x4 rectangle, and you're probably familiar with seeing that in consumer mapping technologies. You can see, this is how you can zoom in and zoom out, right, based on the tile configuration. But the tile has a section of road. Depending on how detailed you want to get, you can get, really zoom in and see on the, per kilometer basis, what is, the representation of the world, right? And so within the tile data structure, you need to be able to have all of the features that are present in reality within that tile.
Got it. So, over to you, Patrick. Can you talk us through a little bit of the architecture that you used in the prototype?
Yeah, sure. So from the discussion, you can kind of hear that there was two main segments. I break it down into the ingestion pattern and then the query pattern. So the way we went about this in the prototype is we intentionally boxed these two functions into step functions, a service on AWS that allows us to orchestrate these complex systems. So with the ingestion pattern, what we decided to do was we needed something that was capable of scaling, but also leveraging some of the serverless capabilities. So in that ingestion step function, we utilized the service AWS Glue. You would have heard illustrations about these tiles. Each of these tiles contain a complex join of different nodes and linkages. So with Glue, what we were able to do is we were able to essentially stitch these tiles together and pump them out into another service known as OpenSearch, a queryable system. Now on the query side of things, so this query step function, we then leveraged a logical path to be able to decipher the user's query. For example, find me a road on an intersection. We use natural language queries to then convert this into a queryable system that we can then run against OpenSearch, leveraging Amazon Bedrock, an LLM managed service on AWS.
Nice. And you talked about the scalability. Maybe, Kristin, can you give us an idea of that scale? What is the, in the end state, what kind of complexity are we looking at and scope? Mm-hmm.
So the complexity, so from a scale perspective, for example, on the tiling scale, we have hundreds of thousands of tiles at continental scale, right? So there's a lot of complexity within the tile structure, and then the data structure, right, is very complex within it. So because we have to have the data representative of the entire road infrastructure globally. So when you're talking about the amount of data, it's very complex and very heavy.
Got it. And then moving then to the NLP area where you're going to allow your users then to construct queries and interrogate the data and the systems to set up these simulations. Is that the next step?
Yes. So a bit more on the natural language. So whilst we're using Bedrock and step functions, more specifically, we're leveraging capabilities such as tool use. So that's quite a new feature on Bedrock that allows us to extract specifically the aspects we're looking for. But the next steps of this queryable section is that we take in the natural language, we then prompt it using prompt engineering. We ask it specifically to generate a queryable system similar to SQL, but specific to OpenSearch, leveraging tool use, so a few joining points there, to generate that query. We then query OpenSearch, seeing if we get the appropriate results. If we don't, we rehearse this. So we reverberate, as what I like to say, correcting the prompting each turn. I believe configurable up to 10 times, but each time you query, you can actually finely tune it so that you guide the LLM to the query you're seeking.
So Shane, sounds like we made some progress building some components to the prototype. What were the key milestones that we were trying to achieve here?
Yeah, great question. So as I mentioned earlier, every time we begin an engagement with a customer, we go through a working backwards approach. And I mentioned earlier the business challenge and the objectives, but one of the other big things we do is try to come to what those core success criteria are for the customer in this prototype. We want to make sure that we have kind of a true north, that we know we're hitting the big ticket items that are going to help move them forward. And in this case, the three things we really focused on, one was creating kind of a scalable pipeline to ingest the data from their tile system. As you've heard, it's very, very extensive. The second part is really putting that into a queryable database for use by the end user. And then the third piece really being important is that natural language component that allows a user to search, find, and obtain really those scenes that they need in that instance.
Mm-hmm. So, Kristin, maybe you can zoom out for us. Can you help contextualize why these three aspects were so important to test out and what they mean in the overall context of the work that you're doing?
Yeah, absolutely. So I think that this is really a critical thing for our customers because they do so much of their testing in simulation. It's been discussed that, for the industry, for a fully automated vehicle to come to market, it might take somewhere in the realm of 8 billion miles of driving to test all different kinds of scenarios We know some companies that do 1,000x the miles in simulation versus in reality, because right now there are only two ways to actually test these systems: is in reality or in simulation. And so for some companies, that means getting out there and driving every mile. We know customers who have driven every kilometer of every lane of the network before actually bringing the functionality to market. And so having the ability to also, do large scale simulation testing is a really powerful tool to expedite bringing some of these products to market. So having the ability to take, to a scalable pipeline where you could do, multiple simulations running at the same time, and also a large data set of our data where you can, from the customer perspective, they can surface different situations in reality that they would like to encounter and test in simulation. And then also that natural language processing for, again, really the human interaction with the data, and making this, something where a customer could say, okay, I'd like to test, a highway where there's 4 lanes and, a motorway interchange, and, look for various features in our data and surface that up and find that information really quickly. So that way they can then throw it into the simulation and test it.
And Patrick, you were able to build in that ability to do those kind of more complex queries.
Yeah, exactly. So as Kristin was referencing before, we've created an interface to be able to just naturally write a question you're looking for. So one of the tests that we ran from memory was find me a road that is accessible by cars, but not accessible by buses or trucks, for example. You can actually test that from that second step function. So you can go through the individual steps and see it query the database. So we use DLQ, Dashboard Language Query, which is the SQL version of querying Amazon OpenSearch. And then you can see it go through and say, hey, it found a road, but a bus can go on it. So that's not right. So we pass it back into the query system, and then we go again and again till eventually we find the correct query that addresses whether it's an easy query or complex query. The language model is able to break down the core components and generate the result you're looking after, or you're looking for, rather.
And if I may add to that, because that is so important for our customers, as you can search for real world data on publicly available large language model, but the output is not the same, because the output here is automotive grade, it's hallucination free. So you really get what you search for exactly. And that was the target for our prototype here.
Oh, that's wonderful to hear. So we often talk in this podcast, because it's about innovation, that it's not an experiment if you know the answer, right? And that innovation and failure are inseparable twins. There's something here that was particularly challenging, or something that didn't work the way we expected, and we had to maybe take a different direction, Patrick, maybe from a technical standpoint, or even process-wise.
Yeah. So there was a few modifications that we made, definitely throughout the prototype of discovery. One thing I think is a highlight to prototyping, but also a challenge, is acting as a portal to be able to interface with the client's data. So we kind of heard the concept of tiles. This is very specific to here and there storage. And as part of the prototype and the ingestion pipeline, we went through this phase of discovery in understanding the link between layers, let's call them. So layers within a tile, they all have this joining factor that could vary from a road to a junction, but they all have this linking together, which internally to here is knowledge. But part of the prototype was us mapping that knowledge they had into a system or service that they could then easily configure. So originally we had been looking at ideas such as using PySpark on EMR, We were potentially just looking at Lambdas to be able to join this, but we found that AWS Glue was the better portal to be able to do this. For the reason that you could just run a Python environment. So you have other configurable environments, but Python seemed logical. And B, Glue has a much more enhanced feature in being able to scale across ETL jobs. That was one of the challenges that took a little time of talking to people like Kristin and Julian in discovering what that link was. But once we were able to establish a baseline, we were then able to jump over to Glue, create that join, but also push that into the OpenSearch queryable database.
Great. Fantastic. So, Julian, maybe we can go over to you, because I understand that it's your responsibility here to actually take the prototype, the inputs, the learnings that we've had, and bring those into a production capability. Can you tell us a little bit about what that journey has been since Shane, Patrick, and the team left, and also where we are and where we're headed?
So thank you for that. So I can tell you it's been a hell of a ride to develop this any further. And I can tell you, so from the prototype, we are currently going from prototype stage, I would say, to POC stage, so to a proof of concept. And this proof of concept, we are developing further. So what we have talked about is like the first part of our proof of concept now. So finding the right scene. What is so important for our customers is getting the scene into the right format. So we added another portion to our proof of concept. So we can generate scenes now in the OpenDrive format, and OpenDrive is the industry standard format for simulation. So customers can basically now search for a scene, get multiple results, pick the right scene, and directly convert them within our tool into OpenDrive and perfectly ingest them in any sim platform software that is out there in the market. And that is the part of the proof of concept. I'm already starting showing the proof of concept behind closed doors to our customers. So we are doing that in terms of getting the right customer feedback to it, like getting early traction to the proof of concept, but also getting requirements, like understanding, is that really meeting the needs of our customers? If not, we are going back and changing things. And from there, I have a lot to do, actually, because it drives me to productization. So how to create a real product out of the proof of concept. And that means we need to talk about the business model, for example. So how is that going to be sold to our customers? What are the TNCs behind that to create a real product out of it then?
Wonderful. Well, thank you all for being here with us today. I'm just wanting to end on some reflections, and I'll start with you, Patrick. What did you learn from this prototype? You have experience across multiple industries. What did you learn on this one?
So working with here, I think, was a real end-to-end experience in the sense that you have the visual cue being the simulation, the Gen AI aspect of mapping something dynamic to structured, and then a huge scalable ingest. It's my first time working with kind of geo-positioned or geographical data points. So one thing I did learn is just the vast size of mapping data in general. It stunned me that we restricted the prototype to a geo, but just understanding the intricacies, I can definitely see why a platform like AWS hits a few critical aspects, such as ingest, query, and output. So yeah, that was one thing that really I reflect back on, is just the vastness of mapping data in general. And once you're able to streamline this process, there's a lot more use cases that open up at the end.
Something we all use on a daily basis, but take for granted about. Shane, how about you? Any reflections that you would share with our listeners?
Yeah, my biggest reflection from this engagement is really, and it's something we talk about in every engagement, but it's the concept of the engaged stakeholder. As Patrick's hinted at, we're not mapping experts. We bring experts in AWS technology and in rapid prototyping, but we are not the experts in mapping. And that was the most important thing in this project that led to the success, is how engaged Here was from the very beginning to help essentially teach us much about their business that we had not been exposed to before. So I think, not only in this engagement, but all of them was a critical factor and is really one of the most important items when we look at what makes a prototype successful.
So important and exciting too, to bring that people from different areas of expertise together towards a common goal. Julian, how about you? What would you reflect on?
I have to say, it was for me also the first time working together with AWS. And the best about it, it doesn't end. So I still engage more and more together with AWS. And I can just say I enjoy it so much because the people within AWS, it's just what makes me smile every day, because there is such an intrinsic motivation in all the AWS folks I'm working together with to make our products even better. And it's a partnership approach that we bring something together to the market that is even better as a joint team.
Well, that's wonderful to hear. Thank you for that. And Kristin, final words for you. What reflection or guidance would you give to listeners who might be undertaking a similar journey?
Yeah, I think, one of the things that, Julian and Shane touched on as well, right? This was really about the value of partnerships. And we have our expertise in mapping and automated driving. Amazon has their expertise in the scalability of the systems and some of the AI components. And when you really lean on your partners and solicit engagements with folks who have expertise in other areas, then you can actually bring something, really remarkable and unique to the market that you might not be able to do on your own.
Lovely. Well, Kristin, Julian, Shane, Patrick, thank you for being here today.
Thanks for having me.
Thank you very much.